Hello student, in previous lecture we have discussed about the squeeze theorem and D'Alembert ratio test to check the convergence of sequence. Now today we are going to start boundedness of sequence. Boundedness of sequence. So first, bounded above. A sequence xn of real numbers is said to be bounded above if there exists a real number m belongs to R. There exists a real number m such that xn is less than or equal to m for every n belongs to n. If xn is less than or equal to m for every n belongs to n, then we can say that this sequence xn is bounded above, and this m is called upper bound for sequence xn. For example, if we take xn is equal to 1 upon n, sigma xn is equal to 1 upon n is equal to 1 to infinity, then if we write some term of the sequence, then it is 1, 1 by 2, 1 by 3, 1 by 4 and so on. So what are the upper bound? M is called upper bound of the sequence. So we want to determine a real numbers that all these terms are less than or equal to that number. So if you observe, all these terms are less than or equal to 1. All these terms are less than or equal to 1. Then 2, 1.1, 1.2, 1.3, 100. They are all what? Upper bound of this sequence, because each term of this sequence is less than or equal to all these numbers. There are infinitely many upper bound for this sequence, or this sequence is, since it has an upper bound, therefore you can say that this sequence xn is bounded above. Sequence xn, that is which is equal to 1 upon n, it has an upper bound, is bounded above. Bounded above. Similarly, a sequence xn of real number is said to be bounded below. A sequence xn of real number is said to be bounded below if there exists a small m, there exists a real number m such that m is less than or equal to xn for every n belongs to n, then xn is called bounded below, and this m is called lower bound. M is called a lower bound of sequence xn. Okay. So when we say it is a bounded below, if there exists a real number m such that m is less than or equal to xn for every n belongs to natural number n. Okay, and then small m is called lower bound of the sequence xn. For example, if you consider this example, xn is equal to 1 upon n, then all these terms are greater than or equal to what? 0. All these terms of sequence are greater than or equal to 0. Then minus 1 is greater than less than or equal to xn. Then minus 1.99. They are all lower bound for this sequence xn. All these are the lower bound of this sequence. We can write minus 0.99, they are also less than or equal to xn. Each of these term less than or equal to minus 0.99, then minus 0.5 less than or equal to xn, minus 2 less than or equal to xn, minus 5 less than or equal to xn. So there are so many lower bound for this sequence. But if there exists at least one lower bound for the given sequence, then we can say that the given sequence is what? Bounded below. Now, take one more example. If we take xn is equal to, n equal to 1 to infinity. Okay. Now we want to check whether this sequence is bounded above and bounded below. So if we write some few terms of this sequence, that is 1, 2, 3, 4 and so on. So you cannot find a single real number such that all these numbers are less than or equal to that number. Okay, so this sequence is not bounded above. Okay, so this sequence is not bounded above because there does not exist a real number m such that all these numbers are less than or equal to m. So it is not bounded above. And since all these numbers are greater than or equal to 1, all these numbers are greater than or equal to 1 or 0, so this sequence is bounded below. Yes, it is what? Bounded below. If we take one more example, suppose xn is equal to minus n. Xn is equal to minus n. Minus n equal to 1 to infinity. Then again, if you write few terms of this sequence, that is minus 1, minus 2, minus 3, minus 4 and so on. Again, all these terms are less than or equal to xn is what? Less than or equal to minus 1, or all these terms are less than or equal to 0, 1, 0.1, 2. So there exists infinitely many upper bound for this sequence, and therefore this sequence is bounded above. Yes, it is bounded above. Yes, this sequence is what? Bounded above. Now, whether it is bounded below? No, you cannot find a small m or number such that all these numbers are greater than that particular number, or there does not exist m such that m is less than or equal to xn, and therefore it is not bounded below. Not bounded below. Now take one more example. xn is equal to minus 1 raised to n. Xn is equal to minus 1 raised to n. So if you write few terms of this sequence, for n equal to 1 it is minus 1, for n equal to 2 it is 1, minus 1, 1, minus 1, 1 and all. Okay, this sequence is bounded above as well as bounded below, because all these terms are less than or equal to 1 and all these terms are greater than or equal to what? 1, minus 1. So this sequence has a upper bound as well as lower bound, and therefore this sequence is bounded above and bounded below. Okay. So next our definition is what? Bounded sequence. So when we say a sequence xn is a bounded sequence, xn is called bounded if it is bounded above as well as bounded below. Okay, so if given sequence is bounded above as well as bounded below, then we can say that the sequence xn is bounded. Or in small m and capital M belongs to R such that m less than or equal to xn less than or equal to m, then we can say that the sequence xn is what? Then we can also say that xn is bounded. Or if you are able to find a number single m such that mod of xn is less than or equal to m, then it is also called, sequence xn is what? Bounded. So bounded. Okay. Then it is also called a bounded sequence. If you are able to find a real number capital M such that mod of xn is less than or equal to m, then it is also given sequence is what? Bounded. It is if and only statement. For example, how to find this m? Suppose if you take the xn is equal to 1 upon n, and if we write two terms of the sequence, that is 1 by 2, 1 by 3, and so on. So all of we know that this sequence lie between 0 and 1. 0 and 1. So if you take the maximum of these two numbers, what is the maximum of 0 and 1? It is 1. So it is also lie between -1 less than or equal to x and less than 1. But from the real number chapter we know that if minus a less than or equal to x less than or equal to a, then we can write mod of x is less than or equal to a if our a is positive. A is greater than 0. Okay, so 1 is greater than 0, so we can write mod of xn is less than or equal to what? 1. Less than or equal to 1, because if all these terms are lie between -1 and 1. So you can write this statement as mod of xn is less than or equal to m. You can find a capital M. Now next, one theorem is there. So you can say that this sequence is bounded. But if you take this example, xn is equal to, if you take the example xn is equal to 1 up n, then this sequence is not bounded. Why? Because it is not bounded above. Since it is not bounded above, and therefore it is not bounded. Because a sequence is bounded if it has a lower bound also and upper bound also. Therefore this sequence is not bounded. Similarly, if you take the example of sequence xn is equal to -n, then this sequence is also not bounded. Why? Because this sequence is bounded above but not bounded below. It has no lower bound, and therefore again it is not bounded sequence. But if we take the example xn is equal to -1 raised to n, then this sequence is bounded above as well as bounded below, and therefore this sequence is what? Bounded sequence. Now next, there is one theorem: every convergent sequence is bounded. So when we say a sequence is a convergent, if it has a finite limit, if the sequence has a finite limit, then we can say that given sequence is convergent. And up to this lecture, how many methods we have discussed about the convergence? You can directly show by using Lagrangian definition. Second, you can apply Squeeze theorem, or you can apply D'Alembert ratio test. So this now theorems: a sequence xn or every convergent sequence xn of real number is bounded. Okay, so what is given? A convergent sequence xn of real number. What is our claim? We want to prove that the given sequence xn is a bounded. That is, we want to show that it has a lower bound as well as upper bound. Now, since xn is a convergent sequence, what this implies? Limit n tends to infinity, xn is exists and say it is equal to L. But what this implies? This implies if you take any epsilon greater than 0, there exists a natural number k such that xn minus L is less than epsilon for every n is greater than or equal to k. Okay, where epsilon is what? Greater than 0 and k belongs to n. This is the definition of limit of sequence. So if limit exists means what? If you take any epsilon greater than 0, you can find a natural number k such that xn minus L is less than epsilon if n is greater than or equal to k. Now I am taking the epsilon is equal to 1. Since it is a greater than 0, this implies since limit exists, there exists a k belongs to a natural number n such that xn minus L is less than 1. Xn minus L is less than 1 for every n is greater than or equal to k. Now we know that from triangle inequality, what is the triangle inequality? Mod of a plus b is less than or equal to mod of a plus mod of b. We are going to use this triangle inequality to prove this theorem. So I am writing here the xn, mod of xn as mod of xn minus L plus L. I am adding plus L and subtracting L. So by using, so say this is A and say this is B. So if you apply triangle inequality, this is less than or equal to mod of xn minus L plus mod of L. This is less than or equal to mod of xn minus L less than L. Okay, but what is mod of xn minus L? It is less than 1 for same k. Okay, for if you take less than or equal to 1 plus mod of L, if we choose our n is greater than or equal to what? K. For this k, mod of xn is less than or equal to 1 plus mod of L. So up to this, how many steps you have skipped? आतापर्यंत आपण काय केले बघा, आपण हे स्टेटमेंट ट्रू आहे. कधी जर आपण अशा टर्म घेतल्या, अशा जर सिक्वेन्स, अशा जर काही टर्म स्किप केल्या, किती टर्म स्किप केल्या अप टू k पर्यंतच्या, इतक्या जर टर्म मी स्किप केल्या तर बाकी सारी सिक्वेन्स बाउंडेड आली बघा. बट व्हाट अबाउट द रिमेनिंग टर्म ज्या k पेक्षा लहान आहेत. Okay, so for that we are going to select capital M is equal to maximum of mod of x1, mod of x2 up to dot mod of xk and 1 plus mod of L. So या सगळ्या मधला जो maximum आहे ना, x1 to xk and 1 plus L. If we select this M, then what happen? Our mod of xn is less than or equal to M. But mod of xn is less than or equal to M implies our sequence xn is bounded. And this is what we want to prove. So hope you understand. Now next theorem, one more theorem. Let xn and yn be two sequences such that